In this video, the problem we're going to solve requires the use of Newtonian physics, because this branch of example problems is based off of statics, which is one of the fundamental classes for many branches of engineering. So Newtonian physics are based off the principles that Isaac Newton observed and developed in the 1600s. And for our purposes, Newton's three laws are what's going to be primarily used to solve statics problems. So Newton's first law is that a particle at rest will stay at rest, and a particle in motion will stay in motion unless acted upon by an unbalanced force. So that basically means that if we have a particle here that's experiencing a force from this side and a force from this side that are both equal in magnitude, nothing will actually happen to the particle and it remains motionless. Now, moving on to Newton's second law, what we have is a particle acted upon by an unbalanced force accelerates in the direction of the force with proportional acceleration. If a particle has a mass, then it can be expressed with this relationship where force is equal to mass times acceleration. And in this case, what we end up happening is if we have a force of magnitude F pushing on this particle in this direction, then this particle will experience an acceleration in this direction of magnitude A, which is proportionally related to the amount of mass that the particle has. Now, Newton's third law, and the final one, is that the mutual forces of action and reaction between two particles are equal, opposite, and collinear. And this just basically means that if we have two particles that are being pushed against each other, like so, the force from this particle, particle A pushing on particle B, is going to be equal to the force from particle B pushing on particle A. So that basically just means that F is equal to F. And collinear means that they should occur in a straight line, but I didn't quite draw a straight line. So using these principles, we can then tackle a large variety of problems. And the problem we're going to deal with today is this one. If the magnitude of the resultant force is to be 9 kilonewtons directed along the positive x-axis, determine the magnitude of the force T acting upon the eyebolt and its angle. So the first step to solving this problem using Newton's laws would be to draw a free body diagram to model all the forces we're dealing with. So we'll do that first, where we have our axes that we want. We're going to have our x direction and our y direction. And then we have the force of T going up in this direction. That makes this angle here. And then we have the force of 8 kilonewtons going in this direction at an angle of 45 degrees. And then these are supposed to add together to result in a force that is going to be along the x-axis and have a magnitude of 9 kilonewtons. So once we have our free body diagram here, we can begin setting up the problem. Now, since we don't want any motion to occur, we can use Newton's laws and basically start with our force is equal to mass times acceleration. And since we have no acceleration, we want no acceleration because we want this to remain stationary. hence the statics, where statics just means stationary or non-moving. We set our A being equal to 0, and so then we end up with this collecting to result in a force equal to 0. So we want the summation, or the addition of all of our forces that are acting together, to be equal to 0 in our reference frame. So the next step is to then break our forces here into components and then use those to solve the problem for each direction that we're acting in. So first we'll break them into X and Y components. So we have our positive X direction, and then we'll go summation of forces in the X direction is equal to 0, because that's the result we want. And then we'll relate this to the breakup of our above free body diagram, which I'll pull down here so it's easier to work with. So we have our summation of our forces in our X direction. We want that to be equal to 0. So if we take our component here, we can break this down into the amount of force that's acting along the Y and the amount of force that's acting along the X due to the T. And so then in equation form, that'll end up being T sine of theta plus 8 kilonewtons cosine of 45 is equal to 9 kilonewtons. And this basically is a result from adding up the amount of force that this T is creating in the X direction going this way with the amount of force that the 9 kilonewtons is creating in the X direction going this way, and the amount of force that the 8 kilonewtons is creating in the X direction. And then we can do the same thing with our Y direction, with the positive Y being up. So we have summation of forces in the Y direction is equal to 0, which is then equal to our force T cosine of theta, this angle here, minus 8 kilonewtons times sine of 45 is equal to 0, because we don't have any resultant magnitude going in the Y direction. So once we have these two equations here, we can basically just use algebra to solve the rest of the problem. So for the X direction, we can take T sine of theta plus 8 kilonewton times cosine of 45 equals 9 kilonewtons, and then break that down by subtracting across our 8 to get T sine of theta is equal to 9 kilonewtons minus 8 kilonewtons times cosine of 45. And then we can solve for our cosine value and get 9 kilonewtons minus 8 kilonewtons times 0.707, 107, which reduces down into 9 kilonewtons minus 5.65, 6854 kilonewtons, which results in us getting one equation, which is T of sine theta is equal to 3.34145 kilonewtons, which is just the result of evaluating this. And then for our y direction, we can go up so we can still see what we're doing. For y, we can take our equation that we have here, this guy, and place it down here. We have t cosine of theta minus 8 kilonewtons times sine 45 is equal to 0. And we can solve for t cosine again by subtracting the 8 to the other side. So we end up with t cosine of theta is equal to 8 kilonewtons times sine of 45. And then we can just evaluate that to get our second equation of t cosine theta is equal to 5.65685. And that is because sine 45 and cosine of 45 are both equal to this, the 0.707107. So we can just take this value and move it over here. So now once we have these two, our next step is to quickly grab an equation 3, which we'll need later. We can get that by solving for t. So we'll take this and just divide by the sine of theta. So we'll end up with 3.3431445 divided by sine of theta as being our equation 3. And now since we have a cosine and a sine, we can use the trigonometry identity of tangent of theta is equal to sine of theta divided by cosine of theta. So that'll basically just end up being equation 1 divided by equation 2. And so when we do that, we have the force of the tension of that rope times sine of theta is equal to 3.343 rounding, all divided by the tension of the rope times cosine of theta is equal to 5.6568. And so then, since we're dividing by these two, our t's can drop off because they just divide out. And so we end up with this being equivalent to sine of theta over cosine of theta is equal to 3.343 divided by 5.6568. And since we know that this here is just equal to that, we can substitute and get tangent of theta is equal to 3.343 divided by 5.6568. And once we have this, we can take the inverse of tangent. Tan inverse of both sides sometimes called arctan, and then end up with our angle theta being equal to the tangent inverse of 3.343 divided by 5.6568. And then we can just solve this by punching it into a calculator and end up getting a theta equal to 30.5818. Now that we have this angle, we can take equation 3 from up above that we solved for earlier to find our tension in our rope. Equation 3 says that the tension in the rope is equal to 3.343145 divided by sine of theta. And since we now have our sine of theta, we get 3.343145 divided by sine of 30.5818, which is equal to 6.571 kilonewtons. And so this ends up being the answer to our initial question, where we solved for and got an angle of 30 degrees, roughly, and a force magnitude of 6.57 being required in this direction to generate a resultant force of 9 kilonewtons along the x-axis. So hopefully this video was helpful, and I apologize for it being a bit lengthy, but that's just going to get worse and worse as we start tackling these more and more difficult engineering problems. Hope you enjoyed, and thank you for watching.